In this video, we will learn about composition of vectors and the laws of vector addition. The resultant of two or more vectors is that single vector which produces the same effect as the individual vectors together would produce. The process of adding two or more vectors is called composition of vectors. As the vectors have both magnitude and direction, so they cannot be added by using ordinary rules of algebra. Vectors can be added geometrically. Here in the diagram, the vector addition of collinear and anti-collinear vectors is shown. You can see in the first figure a vector whose magnitude is 5 and another vector of magnitude 5, and both the vectors are in same direction. So the resultant will be a vector whose magnitude is 10 and in the same direction as of the given vectors. In the second one, the first one is the same as above, but the second one is of magnitude 5, but direction is opposite. So the value will be 0. In the third case, it is first vector is 5 and along x-axis direction 10 vector magnitude is along x-axis, and therefore the resultant will be the sum of the magnitudes 5 plus 10, 15 and x along x-axis. In the fourth figure, a vector along x-axis having magnitude 5, another vector of magnitude 10, but the direction is along negative x-axis, and the magnitude of this vector is greater than that of the first one. So the net direction will be of this vector. So the resultant will be 5 minus 10, that means minus 5, and the direction will be towards negative x-axis. So you will say that the resultant vector is having magnitude 5 and is represented along the negative x-axis. Similarly, you can solve the next two figures. Following three laws can be used to add two or more vectors having any inclination to each other. First one is triangle law of vector addition. For adding two vectors, parallelogram law of vector addition for adding two vectors, and polygon law of vector addition for adding more than two vectors. Firstly, we will study the triangle law of vector addition in detail. If two vectors can be represented both in magnitude and direction by the two sides of a triangle taken in the same order, then their resultant is represented completely both in magnitude and direction by the third side of the triangle taken in the opposite order. Now let's derive the triangle law of vector addition. Here in the diagram shown, there are two vectors P and Q acting on a body and represented both in magnitude and direction by sides OA and AB. So you can see that starting from O, the P vector is moving from O to A, and then we have taken the Q vector from A to B, means along the two sides of the triangle taken in order. Let theta be the angle between the vectors P and Q. You have to take the smaller angle. Let R be the resultant of P and Q vectors. And according to triangle law of vector addition, side OB will represent the resultant of vectors P and Q. And you can clearly see that the order we have taken now opposite. That means we have taken from O to B, not from B to O. So mathematically we can say that vector R is equals to vector P plus Q. Students, take care that we can denote the vectors either by writing the alphabet along with an arrowhead. I have already discussed in the first video of this motion in a plane, or you can represent by the bold letters. Here I have denoted the vectors by using the bold letters. Now expand A to C and you have to draw BC perpendicular to OC. If you are facing difficulty to note down because the diagram is not shown in this slide, so just take a pause and draw the diagram from the previous slide in your notebook and then continue. So from triangle OCB, OB square will be equals to OC square plus BC square, and instead of OC you can say that it is the sum of OA plus AC, and in the triangle ACB cos theta will be equals to base upon the hypotenuse. So AC upon AB, just put the value of AC equals to AB cos Q, or AB represents Q, so you can simply represent Q cos theta, and similarly sin theta will represent Q sin theta. So by putting the values of AC and BC in the first equation, you will get R vector's magnitude equals to P square plus 2PQ cos theta plus Q square under the root. And for direction of the resultant vector, let phi be the angle made by the resultant vector R with P vector. You can also take with Q vector. Then from the triangle OBC, tangent phi will be equals to perpendicular upon base, means BC upon OC. So it will be BC over OA plus AC. That means you can say that tangent phi is equals to Q sin theta upon P plus Q cos theta, and hence you can calculate phi, and if you know phi, then you can find out the direction of the resultant vector with the P vector, because the phi is the angle between the resultant vector R and P. So by using this method, you can find out the magnitude of the resultant vector as well as the direction. In numerical problems, you can use directly the formula of R, means under root of P square plus 2PQ cos theta plus Q square, and for direction, tangent phi equals to Q sin theta upon P plus Q cos theta. But take care here, the P is represented as the base, right? Now the second law of vector addition, parallelogram law of vector addition, it states that if two vectors can be represented both in magnitude and direction by the two adjacent sides of a parallelogram drawn from a common point, then their resultant is completely represented both in magnitude and direction by the diagonal of the parallelogram drawn from that point. So you can see that now the P vector is along OA side of the parallelogram and Q vector is along the OD side of the parallelogram. Starting from the common point O, and let theta be the angle between the P and Q vector. Then if we complete the parallelogram, then the resultant vector R will be OB. The diagonal of the parallelogram starting from the same point O. Now just see the diagram carefully. From O to A and then from A to B, because it is a parallelogram, then from A to B it will also represent the Q vector. Again we have drawn the perpendicular from B to C point, and you can see that again the vector R is making an angle phi with OA. So it just represents the triangle law of vector addition diagram. So the proof is same as we have done in the triangle law of vector addition. You can see that all the steps are same, but if you denote by using different letters, then change accordingly, and ultimately you will get the same magnitude. R equals to P square plus 2PQ cos theta plus Q square under the root, and the direction by angle phi, and that will be equals to tangent inverse of Q sin theta over P plus Q cos theta. In the next video, we will learn the polygon law of vector addition and the numerical problems based upon these laws. Thank you.